contains terms which follow a pattern to determine the next term. Can you find the next two terms in each sequence? I'll give you a second. Or two. Okay, what did we get for the first one? 1632. What happened each time? They doubled each time. How about B? 2536. What's the pattern there? What happened in B? Yeah, you're squaring each term number. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. I know somebody said going up by odd numbers. So you're going up by 3, you're going up by 5, you're going up by 7, you're going up by 9. That could work, but it was supposed to be intentionally squaring. Okay, next one. It's getting bigger by 8. So what would the next term be? 13 and 21. Very good. Okay, next one. This one might be the hardest one. I don't know. Huh? It's on the front. That's a cheater. Yeah. The pattern. Okay, can anybody tell me the next term for D? It is 8, and then the next one, 13. This is a famous sequence. It is! Very good. Fibonacci sequence. And so how are we getting this sequence? Yeah, so 0 and 1 make 1, 1 and 1 make 2, 1 and 2 make 3, 2 and 3 make 5. This has a lot of history if you look up the golden ratio and all that. Okay, next one, E. What's the next one? 1/3. What's the next one? 1/9. It's dividing by 3 each time. How about this one? It's going down by 4, so what's the next one? 1, -3, very good. Okay, notice that C and F are similar. Why are they similar? Huh? Yeah, this one you're adding 8. You're adding 8, and what's happening for F? You're subtracting 4. The next two terms are found by finding a common difference. A common difference could be positive or negative. So in C's case, the common difference was a positive 8, and F's common difference would be a -4. This kind of sequence is called an arithmetic sequence. So when you're adding or subtracting a common number, that's called an arithmetic sequence. So for instance, A is not an arithmetic sequence. It's something called a geometric sequence that we'll learn about. Because what were you doing each time here? You were actually multiplying by 2. That's a geometric sequence. This one is not a geometric or an arithmetic because technically you're squaring it both each time. This would be a geometric because you're dividing by 3, or you could say you're multiplying by 1/3. Yes? And this one we already, so a Fibonacci. Okay, so if the terms of a sequence do not differ by a constant amount, then the sequence is not an arithmetic sequence. So half the battle is knowing what kind of sequence it is. So, can you tell me if the following sequence is arithmetic? If so, you need to tell me what the common difference is. So, is A arithmetic? Yes. And what would the common difference be? +1. So I'll just put 1 for +1. How about B? Yes? And what would the common difference be? What's the common difference? -4, yes. Okay, is C? No, this is not arithmetic. What does anybody remember what that would be called? Geometric. Geometric. Okay, how about this one? Yes. What's the common difference? Yeah, 2.6. You're adding 2.6 each time. Okay. How about this one? No. I don't even know what's going on there. Do you? How about the next one? It's not. Okay, in a sequence, each number is called a term and is represented by a T with a subscript, which indicates the term number. So the first, I think that was just the subscript just carried on to the next line, sorry. The first term would be considered T subscript 1. The second term would be called T subscript 2. And the nth term would be T subscript n. Does everybody understand how to indicate term numbers? N is any number. That could be. Okay. In the sequence 3, 5, 7, 9, ... T1 would be 3. T2 would be 5, etc. The common difference, D, is 2. What are the values of 3, 4, and 5? Term 3, 4, and 5. So term 3 would be 7, term 4 would be 9, and term 5 would be 11. Could we find term 100 without writing out all the terms? How many D's would we need? So, common differences. So let's see if we can come up with the formula here. If we start with the first term and we add the common difference, we get to the second term. Does everybody see? If we take the first term and go to the third term, how many common differences would we be adding? 2 of them, right? If we take the first term and we go to the fourth term, yes, does everybody see how we're doing this? So, to get to the next term, we're adding another common difference, but if we wanted to start at the first term and go all the way to the fifth term, how many common differences would we add to it? 4. So I'll give you a second to see if you can find out what term 100 would be. $201 is the correct answer. Did anybody get that besides I heard one person right here? You got it as well? You got it right. Good job. Okay, explain to me how you got 201. Very good. Very good. Well, how did you get it? Why added 1? Okay, so that would be considered a fluke answer. How did you get your... Really? Oh, I see what you're saying now. You're saying the term number 3, you doubled it and added 1. Oh, yeah. That would only work in this one case. unfortunately. The correct way is what Ryland said is he knew that because you see if you're going from first term to second term, you're going up by one difference. To go from the first term to the third term, you're going up by two differences. So the number of differences is one less than the term number. So he knew he had to have 99 differences. 99 times 2 is 198. And then you got to add the first term to it to get to the 100th term. Okay, so again, if you don't understand it, we'll do it in detail here. Does everybody see the first term is one less difference, so there's no differences times 2, because D was the common difference, right? The second term was the first term plus one difference times the number difference. So the third term is 3 plus 2 times the common difference. The fourth term would be 3 times 2. I should actually put what it is. But anyways, the 100th term then, of course, would be 3 plus 99, one less than the term number, times the common difference, which is how we got 201. So can we come up with a formula then? What's the formula? Okay, so I hear one person saying Tn equals T1
plus T plus N minus 1 in brackets.
Okay, did you see that somewhere that you got that? Okay, because that's pretty good. Okay, so does everybody see this is all term 1? Yes? This number, the way it changes is always one less. You see 100 was 99, 4 was 3, 3 was 2. It was always one less than whatever that number was. Yes? And then we times it by D. So this is actually a formula. You get on the formula sheet, but you can also memorize. So let's figure out what term 100 would be. So 1, 4, 7, 10. What's the common difference? Is 3. So let's find the general term. General term is Tn. Tn would be the first term. What's the first term? 1 plus, we don't, this is a general term, so we're just going to use it as n minus 1. Does everybody see that? And what's my common difference? 3. Okay, just for the people that I lost at this point, I'm showing you what I'm doing here. This is the general term. Tn equals term 1 plus n minus 1 times d. That's a plus sign. So term 1 in this case was 1. The common difference in this case was 3. And I don't know what that is, so we can actually do some simplifying here. And what would my simplifying be? Well, this is a product, so we multiply these two, yes? So we get 1 plus 3n minus 3, and that simplifies to be, usually we write the 3n minus 2, okay? So then what's my 100th term? Term 100 would be 3 times 100 subtract 2, yes? 3 times 100 subtract 2, which is 298. You could have done it this way without, you could have went directly from here or here, it's up to you. So you could have done, or first term 1 plus the 100th term, n minus 1 would be 99 times 3. 99 times 3 is 297, 297 plus 1 is 298. You see, either way, either using the simplified version or the one we made the formula, you'll get that. So I'll give you a second to do B, C, and D. B, C, and D. Okay, so remember you're supposed to answer 3 things for each, I put 297 plus 1 is 298. Okay, so what's the common difference here? You're subtracting 4, right? So minus 4 is the common difference. So Tn equals the first term, which is negative 2, plus n minus 1 times negative 4. So if I simplify that, I get negative 2 minus 4n plus 4, so I get negative 4n plus 2. Did you get that for your general term, minus 4n plus 2? So then term 100 would be minus 400 plus 2, so negative 398. Yes? Did you get negative 398? Okay, next one, C. What's my common difference? Did you get 1.5?
Yeah.
Okay, so Tn is the first term, 3 plus n minus 1 times 1.5. So if I multiply that out, I get 3 plus 1.5 n minus 1.5. So did you get 1.5 n plus 1.5? Yes? So term 100 would be 1.5 times 100, which would be 150. Yes? Plus 1.5 would be 151.5. So did you get that? 151.5? Okay, the next one is a very difficult one. You really have to use upper level thinking there. Can anybody come up with a common difference? Minus f plus g, yes, minus f plus g. This would be the hardest thing to get. Does everybody see you're subtracting f and then adding a g to get to the next term? So then if I subtract f, I get the minus f, and add g, I get 2g minus f. If I subtract, I get 2f. Yes? Okay, so the general term then is the first term, which is f plus n minus 1 times. If you want to write it as negative f plus g or g minus f, are you good with g minus f? I don't like starting with a negative. That's a D. So term 100 is f plus, I don't know if I'd want to kind of whatever that, right? 99 times g minus f. So that is f plus 99g minus 99f. So what do I get? 99g minus 98f. Did anybody actually get that answer? Good job. Wow. Hey, look, there's the formula right there in a box. Sometimes we may be given the first few terms of an arithmetic sequence and asked to find other terms of the sequence. To determine the nth term of a sequence, or Tn, we use the formula Tn is the value of the nth term, and T1 represents the value of the first term. N is the term number, not the term value. I didn't spell number right. There you go. N represents the term number, not the term value. So for instance, in the next example coming up, 1, term 1 is the N. The term value for term 1 is 6. Do you understand the difference between value and number? The term number would be 1, right here. The term, like T1, the value would be 6, right? Term 2, the number is 2, the value is 8. Yes? Okay, and D, of course, is the common difference. So find the indicated terms, Tn, for each of the arithmetic sequence. So, what's the first term? 6. What's the common difference? 2 and n. If I have to find term 10, what would n represent? So 10. N is the term number. That's the term number right there, right? So now we're just plugging it into the formula. Tn equals T1 plus n minus 1 times D. So I'm just subbing it in. So I'm finding T10, the 10th term number. That's what I'm trying to find. Equals term 1, which is 6, plus, what's n minus 1? 9, or do I need to write 10 minus 1? I think we're good. 9, and what's d? 2. So, 6 plus 18, use your order of operations, 24. Does everybody see term 10 is 24? Do you see how to do this? It's just a formula. Go, do the rest. Okay, so term 18 is the first term, which is 9. What's happening each time? D is 7, yeah. So plus 17 times 7. So I got 128. You got 128? Yep. What's happening this? What's my common difference? Minus 5, yeah. So term 9 would be the first term, which is negative 4 plus 8 times minus 5. So negative 40 and minus 4 is negative 44. Yes? And what's happening this time? Going down by 12. D equals negative 12. So term 6 is going to be the first term, which is 23 plus 5 times negative 12. So that's negative 60 plus 23. Negative 37? Yes? Okay. Find the number of terms in the following sequences. So basically, I found that term, basically, I'm looking at this one. I found that term 6 was already negative 37. You need to find that as term 6. That's what I'm looking for here. So you're kind of working backwards. Again, it's just a formula. You're working towards the formula, right? So what's term 1? 10. What's the common difference? Yeah, 5. And the last term, Tn, is 250. So we don't know what n is. That's our problem. So I'm going to sub it into the formula. Tn equals term 1 plus n minus 1 times d. So 250 equals the first term, which is 10. Do you see? Tn is 250, yes? Plus, I don't know what n is, so there's no way I can subtract 1, so I have to just leave it as n minus 1. But I do know my common difference is 5. Do you think you could solve this? This is a grade 9 algebra problem now, right? So 250 equals 10. If I multiply the 5 in, I get 5n minus 5. And then usually you simplify things before you start moving things over. So 10 minus 5 is 5, so I get 5n plus 5. Move the 5 over, I get 245 equals 5n. Divide by 5, I get n is 49. What are you talking about? 5 goes into 245. How many times is 5? 4 left over. 5 goes into 45. 49. Grade 9 problem. Not a first world problem, a grade 9 problem. Okay, try B. Try B. All right. Term 1 is 1. The common difference is 3. Term n is 121. 121 equals 1 plus n minus 1 times 3. 121 equals 1 plus 3n minus 3. 121 equals 3n minus 2. 123 equals 3n. N equals 41. Okay, any questions? Huh? Okay, the 14th term is 78 and the 19th term is 193. Find the common difference. Oh my. Oh my. So how are we going to do this? So I think this is, I'm going to make what you did, it was absolutely correct. I'm going to show you exactly what you actually did. So does everybody see, this is term 14, then you have term 15, term 16, term 17, term 18, term 19, right? And this was 78, and this was 193. So just to show you algebraically what Dylan did is, essentially he made this term 1, new term 1, and this would be now 2, 3, 4, 5, 6, term 6. Does everybody see that? So now, if you know term 1 and you know term n, you can find the common difference pretty easy, right? That's just like the last questions. Yes? I'll go back and show you. You see, I know the first term, but don't know the last term. But when I got here, I knew the first term and the last term. I didn't know how many there were. But I do know how many there are in this one. I just don't know the common difference. So it's just algebra, just solve for the unknown, right? So term n would be terms, I'll just write out the formula first. How about this? Plus n minus 1 times d. So term 6 is 193. Term 1 is 78. Plus, the reason why Dylan said it was 5 is because 6 minus 1 is 5, do you see? And we don't know what d is. So he said he subtracted, the logic was really good. So he subtracted the 78, and he got, what? What, 15? Yes? Is 5d? Did I do the math right there?
Yeah.
And then divide, you get 23. So there's my common difference. Okay, now, does everybody see for B, it's asking you for the first term, not this. That's why I put a little star by this. This is not really the first term. This is the 14th term, right? So now that we know the common difference, we know Tn, supposedly. We can either use the 14th term or the 19th term, and then we can solve what the first term is. Or you could subtract the common difference from this, 13 times. But you're not going to do that. So, again, we're going to put it into this formula. Let's use this term as the 14th term now, okay? So the 14th term is 78. The first term we don't know. So that's what we're solving for, T1. N minus 1, if it's the 14th term, what's n minus 1 going to be? 13, and we already figured out the common difference, which was 23. So 13 times 23 is what? 299? Yeah? So 78 equals term 1 plus 299. If I subtract, what's term 1 going to be? Negative 221? That's what we have to find for B. Okay, let's find the 17th term now. How would I find that? Again, it's the formula. Term 17 is the first term. I know the first term is negative 221. I know n is 17, so what's n minus 1 going to be? 16. And the common difference is 23. So I'm going to give you a second to finish C, D, and E. Did you get 147? Okay, so you could have done what... sorry. This one, does everybody see the 17th term? If you subtract 23 and then subtract 23, you would get the same answer, for sure. Okay, these are little markers at this point. Most of the marks is finding those unknown ones. So the 30th term, did anybody get the 30th term? You're just doing it right now. Okay. Okay, so that would be the first term, which is negative 221, plus n minus 1, which would be 29, times the common difference, which is 23. And you should get 446, right? Okay, so the generating formula, again, you're plugging it into Tn equals term 1 plus n minus 1 times d, right? So we know what term 1 is and we know what d is. They just want the simplified version of it. So term n is the first term. What was the first term again? Negative 221 plus n minus 1, and the common difference was 23. So if I multiply that in, my generating formula would be 23n. And then if I multiply this, I get minus 23. And what's minus 23 and minus 221? Minus 244. So if I were to ask this question first, you might go to find the 30th term, go directly into this and go 23 times 30, subtract 44, right? Otherwise, you can do it this way. So it's like you're getting two formulas, but essentially this is just a simplified version of it. Okay, example 7. Find a formula for the nth term of arithmetic sequence whose common difference is 5 and second term is 12. Okay, so I'll give you a second to figure that out. It's very similar to the previous example. Okay. So D equals 5 and term 2 is 12. So how did you figure this out? You didn't figure out A? Yeah. When they give you term 2, it's pretty easy to find term 1, right? It's 7. So then to find the generating formula would be Tn equals the first term plus n minus 1 times 5. So this would be 5n minus 5 plus 7 is plus 2. So did you get 5n plus 2? Okay, so then the 18th term, it's up to you which formula you use. You can either use this formula or you can use the T1 n minus 1 times d. Either way, you are going to get 92. Did you get 92? Okay. Generate the first 8 terms of the sequence defined by Tn equals 3n minus 2. So what's the first term? What's the second term? Huh? What's the second term? 4. What's the third? Does anybody not know how I'm getting these numbers? First term means n is 1. So 3 times 1 is 3. Subtract 2 is 1. Second term, that means n is 2. 3 times 2 is 6. 6 minus 2 is 4. So what would my next one be? 7. Then what? 10. After this, you don't probably want to use this formula. You just want to probably go up by 3. It's much easier. 13, 16, 19, 1, 2, 3, 4, 5, 6, 7, one more. 22. Represent this arithmetic sequence as a graph. What kind of graph do you get? Now, if all the terms are positive, does it make sense to do an XY axis that is a plus sign? No. It makes more sense to do a one quadrant graph, right? Okay. So here is my axes. And if my ends, this is going to be my ends, and this is going to be my T ends. Yes? So if you want, I can go 1, 2, 3, 4, 5, 6, 7, 8. Will you be able to do this by ones here? 2s. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Yes? So I'm going to plot. The first term is 1, and then I get 1. The second term is 4. The third term is 7. The fourth term is 10. The fifth term is 13. The sixth term is 16. The 7th term is 19, and the 8th term is 22. What kind of graph do you get?
Linear.
Yeah. This is a linear. However, can I actually draw a line through it? No. Does anybody remember? Now, this is back in the day, maybe grade 10, but for sure grade 9. What it's called when you cannot, even though it's a linear relation, you can't draw a line because there's no points between these, right? What's that called? Starts with a D. Discrete. Have you heard of that? It's discrete data, meaning like you can't have when you have term 1 and term 2, there's no term 1.5 or 2.3. You know what I'm saying? There's nothing between. So that means you can't actually draw a line because it's discrete. There's nothing in between. When you draw a line, that means there's points between. So look at the slope of this line. Can anybody tell me what the slope is? Up? What? It's 3. And it's the same as your D. It's the same as your D, right? Do you see? It's going up by 3. That's your common difference.
And look at that, we're done here.
Up 3 over 1, yes? Look, you're going up 1, 2, 3 over 1. The scales aren't the same, right? This is going up by 2s, this is going up by 1s.